Well, good afternoon and welcome to the seminar today. I'm pleased to announce one of our distinguished CERIAS alumni, and this is Abhilasha Bargov-Spanzel. I said that wrong, didn't I? My apologies. So anyway, she's here to talk to us from Intel, and she's going to talk about digital identity protection, and I will turn it over to her.
Thank you, Jerry. It's lovely to be here. I'm sure Jerry was practicing my name a little bit, at least. Last time I talked, I had half the name, and it was about, 10, 12 years back. And it's, you'll know when you come back 10 years after staying at Purdue how great it is to be back. Today I'll be talking about a certain area which was a part of my research, and I'm very happy to have been pursuing it in my work life. How many of you are grad students? 100%? Okay, cool. And how many are pursuing PhD? Excellent, and others are deciding to do it eventually. Okay, so so this was the topic of my thesis when I was here at Purdue, and I would also show some examples of how to translate some of these activities back to the real world. So getting right to it, as I mentioned, I am a Purdue biochemiker. I spent from 2000 to 2007 at Purdue. I had a lot of fun. Purdue offers so many different majors, and I tried every one of them like a buffet, but it was a lot of fun. A key guiding factor was doing research. Professor Wagstaff, Professor Spafford, and I think 5, 6 other professors who were over the semesters provided a lot of good research experience, and I just gradually went to grad studies. I didn't even realize when I finished my undergrad. This is almost like a home to me. I just remembered last time when I was here, my sister was popping her head, showing her thumbs, like I'm still doing well. I've done a lot of talks, but that was one of the first few, and it's really great to gain that kind of experience at Purdue. And I graduated in 2007 and joined Intel, so I've been there ever since. I'm good with questions during the talk, so please feel free to ask me questions. From here on, it's talking about digital identity. I think it's a topic close to the heart because it applies to everyone. As a consumer, if you are doing it as a big project, so understanding the basics of identity, what is authentication. You all attend the security seminar, so you understand the importance of authentication. We're revisiting the security and privacy requirements. The slides don't go into a lot of details, but I'm happy to get into them if you need to. The idea is to give you an example of a real-world solution and what it took to get it to millions of devices. It takes a lot of effort to take an idea from concept to actual implementation and out there. I would also like to spend some time on some of the newer initiatives, and Ryan will present some of the new things that we are doing with Intel's Makers program, and also the efforts in cybersecurity and also increasing the diversity in cybersecurity and computer science in general. So the first thing, who knows where this icon is from?
From the Lion King.
Lion King. So I'm not a dinosaur age yet. Yeah. So what is identity? I think there are microphones all over, so I can repeat your answer, but what do you think is identity?
The thing through which I can determine who you are.
Exactly.
Please use your microphone.
Okay.
So I think basically the gentleman said that it is how I determine who you are, and that's exactly it. It is a claim made by one subject over, saying this is how I determine, and what are these claims? And it's a claim, you tell me that you're a student of Purdue. How do I know that you're a student of Purdue? You will probably show me some proof saying that here's my badge. Like, how do I know that badge is correct? So you may go up the chain to understand if this particular identity is really what it is. The badge is just one of the things. The idea of how we identify a given user can be determined by multiple aspects, just like a human being, right? We don't just check your badge and say, hello, you know, nice to meet you. It's by checking a bunch of things associated with the user. So it could be what you know, what you have, who you are. Interestingly, our digital identity is becoming very close to our physical one, right? What you wear, what you like, your behavior, it's getting very, very tight. You know, the first talk many, many years back, there was almost a clear distinction between your identity in the cyber world versus your identity in the real world. With the increased personalized services, with the increase of machine learning, AI backend, the learning of who this user is becoming increasingly comprehensive, right? It is using multiple factors, gestures, attributes associated with the user, and then identifying the user based on that. The confidence that I have about a user's identity greatly depends on the quality of these various aspects, as well as the number of them, right? I can potentially compromise the student ID. I won't ask anybody to raise their hands who've counterfeited student ID to get into the chocolate shop or something, but everybody's a grad student here, so that's probably not an issue. However, compromising other factors, you know, compromising your biometrics along with compromising your ID card may be slightly harder. So the probability of spoofing a user's identity when you add the number of factors and strong factors becomes less. So there's an increased need for strong identity. And as you will see, who can see where the role of identity is in this? Is it in 1, when you obtain the credentials, 2, when you plant the malware, or when you gather data, or when you exfiltrate or remove the data from the victim's laptop or other devices? This is a regular anatomy of a breach.
Isn't all of them?
It's all of them, right? So you use social engineering attacks, that's exactly correct, right? You use different types of identity-based attacks. There are 100,000 per day. If you look at a lot of the surveys, the number of user information that is being captured, number one, to plant malware to get additional user information, and then take that information and create data banks and exploit it, is high. And also the costs associated with this are increasing. You know, the number of breaches every single year, you will just see a super big number, and the damage it causes to the user, to businesses, to any kind of vertical that you may be thinking of. So what is essential is our attention to preserving and protecting this identity. So I will put together some examples here. Is anyone aware of any of these examples? Has anybody seen the Anthem where the compromised admin password got it, or IRS? I see a lot of nodding heads, right? So this is not new. Almost every month, or if not every week, we hear something about some login credentials being stolen. And the problem is, one, that we are using those passwords. We should stop using those passwords. And the other is the ability to, you know, fight against social engineering and other things which compromise the password itself or the token that is associated with the user. So identity theft. This is my daughter, who was about 1.5 years old when she started thinking about identity theft. It's not true, but it was funny how the kids, when they are born, as you go on, you will see how much their information is recorded, starting from the very basics, even the DNA sample to a large extent. And all of this is stored, and I don't think people really know how to track it. There are a lot of good identity theft protection services out there, but there is no means or mechanism to really track every possible way of attacking, of figuring out whether your identity has been compromised. And it's not just financial. It's the impact of identity theft is in fraud, whether somebody's trying to use your information to cause healthcare or criminal records, etc. So identity theft goes way into destroying a person's life, and it is, if you go to DEF CON conferences and others, you will see how easy it is to get enough to compromise a user's identity. Social engineering attacks, leading to compromise of user information. Again, in all of the top conferences, they show how you can call some random service which has a lot of information, and how easy it is to get your information from them. If you want to meet me offline, I can show you a few links of how interesting it was to find out your fellow students' home address, where they've lived, how this information is so easily accessible just because of social engineering attacks, phishing attacks. And the points of attacks in an identity system is not 1 and 0. It's not just that one door that you need to put a lock on. The entire identity system has multiple points of attack. You have the sensor itself, where you could put a fake biometric, you could, or credential, you could replay old data. So this is where things start becoming interesting from the technical standpoint. You look at an identity subsystem and you break it into small pieces. You capture the biometric, you transfer it from the sensor to the feature extractor. You can potentially compromise the extractor itself, right? You put another piece of software to override the feature extractor. You can synthesize a brand new feature vector which can go into the matcher, or override the matcher itself. So you may have everything perfect, but you can all you have to do is switch. You've seen some of those movies. You switch the biometric in the back end, and you're matching against the compromised user's biometric. So it's kind of interesting that you just are looking for that weakest link, and many of the times you do everything to protect it from 1 to 7, and all your attacks are protected, but the attacker simply overrides the final decision if it's not articulated properly. So some kind of a replay attack. So this may be simple to you because you're at Purdue and you're studying security, but this is a very hard concept to get through. To understand that it's not just one solution that is going to fix it all. It's looking at the end-to-end system. Also looking at the entire life cycle. The idea of looking at the registration. How did you get your Purdue ID in the first place, right? How did you go to the PMU and do some proofing, show your driver's license, passport, whatnot? How did that proofing happen? In a digital world, you don't have the luxury of doing in-person proofing, so you need flexible registration options. This is where everything fails, by the way, today. There's no way to go back in history and fix it. So being able to proof and register identities correctly in the first place is a big challenge. Making sure the user has choice, this world looking at the privacy and security concerns. Then once you've registered the user identity, looking at the usage. So can anybody, has anybody seen how an identity that was originally issued could be misused? That means there's a function creep. Like I issued my social security, for getting social security services, but you pretty much use your social security number for a bunch of other things, right? That's where the flaw is, and it makes identity theft a lot easy. Does anybody else have another example of usage or function creep, of how identity is used in different ways than originally intended? I don't know if you guys are looking at how the various information that you have for stores and other things, where you get some discount for items. When you provide that information, that can potentially be used for other types of analysis. So there are certain privacy requirements and minimal disclosure depending on how that information is used. There is also maintenance issues. You know, if somebody was to poison the database of identity information, the more you look at it, it's very, very, very interesting. It's not just about looking at your username and password. It will also know when you're smiling or frowning, or, you know, there'll be a lot of your information that would be maintained in the backend. Being able to be notified, be able to make sure the quality of data is correct. So if there's notification, alerts, and finally the revocation, which is very, very hard. Some of the professors at Purdue are working on the revocation, being able to flexibly revoke information that is incorrect about you, or just remove it because you don't want it out there. It's a very hard problem in today's world. So there are numerous opportunities for research, you as graduate students, on each of these areas that has to be done. And one thing that will continue to be a war is between the need for privacy versus security. So who over here believes that the privacy versus security is a contradictory requirement? You either choose one. You either have security and accountability, or you have privacy. You, Simo,
No, I was just agreeing.
you think it's a choice?
I mean, to some extent.
And that is what most of the people think. Do you have a comment?
Use your mic, please.
Yeah, I think if you are super paranoid about your privacy, then you have to let go of security. But I'm specifically thinking of smart homes, because I know when someone's in the bedroom, I know when my gas is leaking or something of that sort. But then I'm giving up privacy, and a considerable amount of privacy. Like, the data is being collected, and the entire point is for them to collect the data so that I know what's happening even when I'm not at home. So I really think it's you choose your, yeah.
Yeah, it's a choice. Choose one. So my thesis was actually to achieve privacy, very highly secure, privacy preserving solution. So not jeopardize privacy, but achieve the level of security. And if we look at the intersection between the two, it's blue and blue and blue. So if you cannot see the Venn diagram, that's fine. But bottom line here is, what you said is 100% accurate, right? It feels as if we are giving away something, and we do have to. But there are certain mitigations. Like, for example, if you know what is the policy of how that data is being collected and being used, and it is not being used for anything else, like nobody's just using it to figure out patterns so that they can sell you something more. Or you have a selective disclosure. It's like, I want this to be revealed, but not that, right? Being able to be notified. So there are certain attributes of privacy that can be achieved while achieving the much needed security and safety. You know, making sure we can have all the confidentiality, integrity, availability, audit, revocability, and so on. So each one of them has a lot of work. If you go into the crypto world, achieving non-repudiation took years, you know, to get to the point where you can be 100% sure that this user indeed did the transaction. So there is a balance between security and privacy, and my challenge to you is to look at your solutions such that you don't have to give up on one to achieve the other. And I think that's an interesting area of research. So one example of how we achieved this balance was based on a product that I've been working on at Intel. It's based on trusted execution technology or trusted execution environment. Are folks aware of what TEs are? No? So essentially, think of it as an isolated, secure area where you can store, execute, and process information. So it can be done in different ways. It can be hardware-based. There's something called the software card extensions from Intel. There's, in the non-Intel world, on the ARM side, there's a trust zone, and you would also have, they are separate parts of the chipset which allow you to have a separate converged security engine which allows you to have this trusted application to run. And when it links to an end-to-end solution, it provides the level of security you need to have a secure solution. So I'll give you an example of how a TE can be used. So when you're collecting the data, you collect it within a TE. Then you have a crypto channel that transmits it securely to your signal processing feature. So that could be some kind of an enclave within your system that is responsible for doing it. So you're going from one trusted execution environment to the other and evaluating if your biometric, which is also protected by that TE, is correct. So once you do that matching with a database that is encrypted and only can be decrypted within that trusted execution environment, then you come up with a final answer, which is a cryptographic token based on keys that are also protected within that TE. So it can be used to harden every aspect of existing biometric or authentication systems. So that is one example of how we achieve a high level of security, but we didn't leave our secure zone to achieve that. So an example is the work that I've been doing at Intel. The product is called Intel Authenticate. It was announced earlier this year. It actually is a hardware-based mechanism to do multi-factor authentication, and it's available anywhere after the 6th gen Intel Core vPro platforms. And essentially think of it as an identity engine in the hardware, which allows you to consume policies which are set by the backend on how an identity is defined and how it is used to verify a given user for various applications. So I really need to make sure that you are who you say you are when you're doing very sensitive transaction. But I may not need everything if I just need you to say enter this class, right? I just need to know that you're a Purdue student. But before we do some high-end bank transaction, they may want to see something more. So depending on the type of services, in this case, whether it's OS logon or logging onto VPN, or we are doing continuous authentication where we figure out whether the user is there or has the user left the system, then we are able to enforce the policies associated with identity in the hardware and release only that cryptographic token. So here is an example where you achieve security and a very high level of security because everything is protected, your identity is protected, your decision is protected, and your enforcement is there because you're sending a crypto token which cannot be spoofed by anyone else. More details, please ask me, and I'll go over one particular use case of how this works. So consider this. Who knows how public key crypto works? Everyone, good. So when you are issuing certificates, then you normally don't know who is issuing it. You just know that you assume that the user is got the private key somewhere secret, right? The whole idea with Intel Authenticate is to tie the certificate with the user's identity. So when we are generating the key pair, we ensure that this key pair is associated with an identity verification policy. When that happens, when we issue that certificate with that public key associated with the user, during verification, say the app, which is the VPN app, is requesting for a sign operation. At that point, it will send a challenge. The challenge will determine the object identifier, think of it as a policy associated with the authentication requirement, and it will be sent to the identity engine. The identity engine will basically check, in this case, what you have. You know, if you have the right phone, then you're the right user. You can use the user's face or PIN or anything else. So as long as the identity engine says, yep, the user is who he or she says he is, then we'll continue and do the crypto operations associated with those public-private key pairs. So I may be able to steal your key, but I cannot use it until that identity is mapped correctly. That's pretty neat, right, for those who've done PKI stuff for a while. So basically this is very important consideration because this allows you to fit with legacy applications. So one of the real world things is you can't really do anything from scratch. You need to make sure it integrates with existing environments. So very quickly on when we were deploying it, there were a lot of aspects of it that we had to cover, starting from making sure that the packages can be deployed in an effective fashion. So it is not just a little ingredient on the platform, it's an end-to-end solution. Being able to associate it with authentication policies that allow you to define and scale from multiple applications to multiple authentication factors. So thinking scale in mind, thinking integration in mind is extremely important to bringing things to the real world. Looking at the factor management, things have to be managed. You can't just do one-off and expect everyone to sort of follow it. Think of how you would manage it, how do you patch it, how it works with the various peripherals and the various drivers on that operating system, because there's no one size that fits all. So that was the end of the identity deep dive. Any questions?
I'm interested in knowing how much is the performance impact when you execute those operations. So I'm interested in knowing how much is the performance impact when you execute those secure operations in trusted execution environments. Because I have looked into some available trusted execution environments in the platform. Either those platforms do not allow developers to access the trusted execution environment, or they are said to be slow. So I'm interested in knowing if the Intel trusted execution platform overcomes those problems.
Yeah, so it's something that we should do. It's an excellent question. The more security add, regardless of where you're doing it, sometimes it slows down the system, which is where it is extremely important, especially as an identity solution, to get out of the user's way. Let the user access the system, versus make it even harder. So that is so we have very strong requirements on the performance indicators. So some of these trusted execution environments don't do everything, right? They'll do the most sensitive part of the operation and have the rest of the CPU used. Software guard extensions, for example, runs on, it uses the entire CPU horsepower. So there's no, but we can go case by case to understand what exactly is the issue, because at least I don't believe there's a silver bullet that you've got to use this trusted execution environment for everything. I think it's a mix and match depending on the requirements and the capabilities of that environment. Yes, please.
So whenever you need to perform any sensitive operation, you go from non-secure world to secure world. So I mean your trusted execution environment. So I'm interested to know, like, how much is the overhead whenever you switch between two worlds? Because like I might be running several other applications which might get affected when I actually have to move from non-secure world to secure world.
Yeah, so our requirements, again, from the performance perspective, are normally very strong. Sometimes we have to do the operations in, say, 50 milliseconds and then get it using the crypto channel. We do pre-caching. Depending on the type of operation that you're doing, there are ways of optimizing it. And it depends on what kind of trusted execution environment you're using. Are you using a hardware-based one, a separate microprocessor? Are you using a virtualized partition? Are you using a separate sensor? So depending on the type of trusted execution environment, you would be able to achieve the desired performance. And there's a lot of advancement on that, so it'll be worth doing a deep dive to understand exactly what that use case is. Yep.
I have a question about your Intel Authenticate platform. Do you rely on TTP? Do you use trusted third party somehow in that scheme?
Yeah, so there is a very interesting, it's a very good question. So there is a trust in the backend to have set the policy correctly.
Mhm.
And it is a very interesting way of ensuring that it is not a blind trust. It is also associated with attestation, which means that you expect that I trust it to do having done the right job, but I'm still going to verify it and using hardware-based attestation.
Mhm.
So there's a trust but verify model with the TTP that we have to have, because the way we designed it is for enterprises, which allow admins to define how you need to authenticate to your system.
So it's sort of mix hardware-based technique and software-based.
Yeah, it's a mix and match of both. But verification using hardware-based techniques, which will allow you to have high assurance that you're not blindly trusting it, you're making it trustworthy.
Yeah, that's a great idea. So it means that if someone stole my private key, it will not work on a malicious machine.
Yeah, we make it hard for someone to steal your private key. So the motto is authenticate locally as much as possible, so nothing sensitive leaves your system, and authorize globally based on the tokens that you release to the world. So we try not to be migrating private keys often, but we carry out the operations and intelligence locally, so that's kind of that balance between privacy and security. Like if I'm in a smart home and I'm trying to do some intelligence, it doesn't have to always leave a certain boundary that you define. So private keys are along those same lines.
And I have a second question. What do you think about zero-knowledge proof authentication?
So the attestation is exactly based on zero-knowledge proofs. If you go back, that was the essence of my thesis also, is using aggregate zero-knowledge proofs to take multiple factors in a very efficient manner without exponential increase in computation. By simple addition in the exponent, you could combine the various types of attributes and do only one proof and show multiple factors have been satisfied. So the use of anonymous credentials and zero-knowledge proof is extremely valuable. The world is not there yet, but we'll get it there one by one.
Thank you.
Yeah, I think zero-knowledge proofs is a great way of getting that balance between security and privacy. It allows you the minimal disclosure that you need as well. Interest of time, I would love to hear more comments, by the way, even after the session. I do want to, I'm requesting your help. You're already in security. You are grad students. I would like to make sure that all of us are ambassadors, to show how the cybersecurity careers and cybersecurity research is well understood, and folks are spending more time, especially the undergrad, as you are TAs and advisors to some of the undergrad community. Security has been there everywhere. I was talking to some folks earlier. They're like, it's not as interesting. Big data is interesting because it's new. It's a new word. And security has been there forever. But you know what? There's a constant evolution. The types of threats that are happening, the rise of attackers, how well organized they are becoming. It scares the hell out of me, on what it can do to our actual physical lives if we don't take care of it. There's more at stake, and there is a need to keep up with it. The role of governments, the role of, the type of cyber offense that affects everyone. I don't know how many of you know people who've been impacted by a security, some digital theft, fraud, some attack. And we have a victim, right? And we either know a person, or it's not like one-off, somebody's password was stolen. Almost every single person, it's not something that you can save yourself by working in isolation. So there's definitely a lack of talent, and I have job recs which are open and looking for good security talent, and it's not there. So it would be very good. And there is also a change in direction. I really like the quote from the Satya Nadella, who says that the next 10 years we are going to take it to a whole from consuming various technologies, we were on this side, to being an age for profound creation, the ability to actually make things, to make, not just rely on companies to make stuff for us and us using it. Every single user, my 5-year-old loves to make things, they expect to do more, and it's that age. And I really like this particular classroom. It's one of the more rare ones where there is a good balance of diversity. Typically I'm sitting and there are 50 people and there's probably one woman, so your help in making sure that there is diversity from every angle, and there is a lot of initiative from Intel to make sure we have a diverse workplace. It enriches the environment, plus it helps it's a really great way to work together, and encouraging co-workers. It can be pretty intimidating for some of the students, especially women who are in undergrad, who will quickly switch to something else unless we give them the mentorship and guidance. So this anything which helps in bridging that gap would be great, and your ideas along those lines would be well appreciated. So and now I would like to hand over to Ryan, who would talk about the Intel's Maker program. So we talked about profound creation. Here is an example of how we can take it beyond the regular PCs, laptops, and understand the make culture.
Thanks, Abhilasha. Appreciate being here. I'm actually a program manager at Intel in the chipset architecture group, and I kind of do this kind of stuff on the side because I think it's fun and exciting. And just a plug for Intel, that's one thing that Intel does allow is for us to do things like this, where I can be involved in promoting makers and also trying to promote and improve diversity in technology. Over the summer, I was involved in a with the local high school students there. So we did a 2-week maker program with them to try to get people early on in technology and help them to understand and know that this stuff is fun, cool, and it can lead to excellent job opportunities later in life. So are you guys all pretty much familiar with what Maker is in general? Is there anyone that have any of you been involved in any Maker projects or done any Maker projects at home? A little bit? What kind of things have you done?
I built a survey program with a Raspberry Pi.
Okay, Raspberry Pi. That's one of the things I like to use. So yeah, so maker culture, it's kind of a philosophy of learning by doing, and it has its roots in kind of do it yourself. So learn things by tinkering, putting things together, taking things apart, and it's been accelerated recently by like low-cost electronic development kits, open source code, 3D printing, and a collaborative economy are different ways that that the maker culture has become this big thing. And now, I don't know if you've ever heard of Maker Fair that happens every year. There's actually multiple ones throughout the country, but the main one is in the Bay Area. So thousands of people come and showcase their creations. Much of it is art and technology focused. And it's just fun. That's basically what it's about. So Intel's very involved in the maker space, and we're trying to become more involved. And we have quite a few different products in that space. One is the Intel Arduino 101. Another one is the Intel Edison board. And we just released a new development kit, which is a little expensive for the maker side. It's called the Intel Joule kit. And it has a lot of image processing capabilities and other things that make it interesting. But like I said, it's a little bit more expensive. And so I just wanted to do a quick little demo of a maker project that I did not do, but whoever did it is pretty awesome. And we'll just showcase that a little bit, and then we'll just talk a tiny bit more. So basically what this is, and you can see on the screen there, this is a rock, paper, scissor robot so that you can play rock, paper, scissor by yourself, which might not be that fun, but it is fun to build it. So what we have here is an Intel Edison board right here. And inside of this little blue box with the hand on it is an Intel Arduino board. And there's a couple of little sensors here that measure basically flex. And if you figure out rock, paper, scissor, you can basically tell everything you need to know from just these two fingers, whether you're doing the paper or the hand, which is, paper, scissors, or rock. You can figure all that out from just these two sensors here. And so I'll try to get it going. Sometimes it's a little finicky, but just put this on here. So if you can pan down, camera down here. So we got a little screen there that shows you who it is. So I'll push the button. It'll count down, and I'm gonna select rock. And you can see the two fingers went down. So he threw paper, and that means that me being player one, I won that round. So hit the button again, just for sport. I'll give it rock again. He did paper again. Not very smart. And it looks like I won that round. So that's just a quick demo. This was all this blue part here was all 3D printed and has open source diagrams. Even this hand here, you can find open source, not code, but plans that you can just load in your 3D printer and print it all out. And then there's just a couple of little motors inside there and this screen. So I think all of this probably would cost maybe less than $100 to make. And we think it's an excellent way of getting more people interested in technology and improving diversity at Intel. So I just had one little other quick slide to show. So yeah, the demo. So yeah, the most important thing about being a maker is you just find stuff on the web. It's freely available. Makers love to share, and they love people to copy what they've done. That's like a big, accomplishment if people are making what you made. And then you take that and you iterate on it. Make it better one step at a time. I came up with some example security projects that are common out there. You can make your own home VPN server. Home surveillance systems using the Raspberry Pi are really big. And you could extend, biometric scanners to everyday items. If you don't want your roommate using your microwave or something like that, maybe you could figure out a way of preventing that using an Arduino and a fingerprint scanner or something like that. So the other thing that Intel is doing, we have America's Greatest Makers. It's a TV show on TNT. I don't know, have any of you heard of it before? We have one or two. So it's kind of like Shark Tank meets other reality shows that you might have seen. People pitch ideas, and they have mentors that help them through the way. And they pick a winner, and the winner gets $1 million to use however they want. They don't even have to use it on their company, and they're not in any way have to work with Intel after that. But they are open casting for Intel makers. So if you have any amazing ideas that you'd like to present, you can go to this website and see the shows for one, and two, sign up and see if your idea might make it as America's Greatest Makers. So thank you.
It's time for... We went through, the topic of identity and the various opportunities over there, just as one of the many areas in cybersecurity. I like it the most, but everybody comes from their own different directions, and everything is extremely valuable on how it puts together. And cybersecurity, just as a field, has so many opportunities, risks, problems that really need to be solved. And there is a gap, right? So highly encourage deep, comprehensive research, understanding the various threat vectors, and you yourself as leaders to guide the way. So if you have any questions, we are here after this session. Happy to answer any more questions, but very much look forward to getting more and more cybersecurity experts coming out of Purdue. Thank you.